Hey there, CJ Math students, and welcome to Notes 2.19. So, first of all, I don't think you have this vocab word on your paper, commutative property. But what the commutative property means changing the order does not change the sum or product. So, for instance, I can do 3 plus 7 and make it equal to 7 plus 3, or I can do 6 times 3 and it's the same thing as 3 times 6. This does not work with subtraction, so write that down. Not work with subtraction. Let's think about why that is. So if we do 10 minus 2, we're going to get 8. But if we do 2 minus 10, keep, change, you can get negative 8. Same with if we do 8 divided by 2, you can get 4. But if you do 2 divided by 8, you can get 1/4. All right? So it doesn't work with subtraction or division. So only with addition. So the associative property says you can change the placement of parentheses or grouping, but it won't change the answer. So if I wanted to say add 4 plus 3 first, then add 1, that will give me 8. Or if I said add 3 plus 1 first and then add 4, that will give me 8. Notice the order of the numbers stays exactly the same, but in this one, the parentheses, the grouping symbol, which tells you which one to do first, that changes. It just kind of shifts over from 4 plus 3 to 3 plus 1. But notice the answer does not change. Same with multiplication. I can do 2 times 3 times 1. Notice the order is exactly the same in both, right? And that would give me 6 times 1, which is 6. Or I can do 3 times 1 first, which is 3, then times 2, which is 6. So the order does not work. Again, does not work with subtraction or division. Now, a good way to go ahead and remember that the commutative property and associative property, like how they are different. Well, commutative has the root word commute in it, and that means to move around. And the associative property, to commute from one place to another, right? The associative property has that root word associate. And associate is like who you hang out with, right? So you can say who you hang with. Right? So who you're grouped together with, right? So those are two good ways to use that. So now we can use these properties to kind of dig into our old toolbox to figure out these different rational number problems. So these look on the surface like very complicated problems, right? But knowing that you know how to convert fractions, decimals, and percents, and knowing that you know how to add and subtract, multiply, and divide fractions, like these actually won't be that difficult. So the first thing you always want to do is go through, look for subtraction. So write that down. Look for subtraction. And when you see that, you want to change that to adding the opposite. So here, minus negative becomes plus a positive, and then minus becomes plus a negative. Right? So now once we've done that, let's rewrite the problem. 4.6 plus 10 plus negative 4 3/5. So here's the deal. You can do this a whole bunch of different ways. But hopefully you recognize that 3/5 is simply equal to 0.6. So really, if I wrote this problem again, it's 4.6 plus negative 10 plus negative 4.6. And now, using the commutative property of addition, don't add 4.6 plus negative 10 and then add negative 4.6. No, recognize that you have the additive inverse here. Negative 4.6 plus 4.6 plus negative 10. This equals 0. And 0 plus negative 10 is obviously negative 10. So it's that simple. So again, you can see this very difficult problem right off the bat, but because you have these tools in your toolbox, such as like, hey, I know what the additive inverse is, I know how to convert that fraction to a decimal, you can make this problem super simple. All right, let's take a look at number 2. So 5.1, and then remember, I see subtraction, so plus a negative, plus a negative, plus a negative 4 4/7, plus a negative 5 1/10. So again, you should be able to say, I know that 1/10 is equal to 0.1, right? So now if I rewrite this, it's 5.1 plus negative 4 4/7 plus negative 5.1. Some of you were like, well, I don't know my sevenths, but look, in the end, you don't have to know what your sevenths are. Right? So work through the problem before jumping to any conclusions about, oh, but I have to do this and I have to find common denominators for this. Like sometimes in the end, you won't even have to do that. Again, we have the additive inverse here, right? So that's 0 plus negative 4 4/7, and there you go. right? Negative 4 and 4/7. It's knowing when you need to use common denominators, knowing when you need to, say, split up that fraction. It's going to be very useful for you. All right, number 3. We got plus positive, and don't do anything with the addition sign, so just leave that alone. So negative 5 and 1/5 plus 3.1 plus 5.2. So let's, again, hopefully you can see, hey, 1/5, I know that. I look on my reference sheet, oh, that's 0.2. So I have negative 5.2 plus 3.1 plus 5.2. And if you didn't know the additive inverse, you might start trying to do different signs, subtract here, and then add the 5.2. But you know that hey, I can see the additive inverse right off the bat. It's 5.2 plus 5.2 plus 3.1. Those guys cancel out to 0, plus 3.1. Boom, done. All right, one more. 32.875 plus negative 12 7/8. Ugh, this looks rough, right? But if you look at your reference sheet, oh, sorry, that should say 32, my fault. 32.875 plus, 7/8. Oh, that's 0.875. So negative 12.875. And now you're like, well, should I line these up and all that stuff? Well, guys, this right here, the 0.875s, those will cancel off. So really, you're just doing 32 plus negative 12, which is DSSM. So that's just 32 minus 12. And you get positive 20 because you had more positives. That's the end of part 1.